Hi students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as rotational. Take down a sum please. The moment of inertia, the moment of inertia of a disc, the moment of inertia of a disc about an axis through the center, the moment of inertia of a disc about an axis through the center, about an axis through the center and perpendicular to the plane is 20 kg meter square, is 20 kg meter square. Find the moment of inertia about a parallel axis. Find the moment of inertia about a parallel axis. Find the moment of inertia about a parallel axis and first part of the question, tangential to the rim. First part of the question, tangential to the rim, and second part of the question, passing through a point, midway, passing through a point midway between the center and the rim, passing through a point midway between the center and the rim. Now, moment of inertia of a disc about an axis passing through the center, about an axis passing through the center and perpendicular to the disc IC is given by the formula mr square by 2. So 20 is equal to mr square by 2. Therefore 40 is equal to mr square. Now I want to find out the moment of inertia about an axis perpendicular to the disc and tangential to the rim. Now in that case I can use theorem of parallel axis. Now distance between center and rim is going to be r, right? So in that case therefore I can say by theorem of parallel axis, IT is IC plus mr square. So IC is 20 plus mr square we have already found out is 20, 40 kg meter square. Next, mr square is 40. So in that case this is going to be 60. Next, about an axis passing through a point midway between the center and the rim. Distance between center and midway is going to be r by 2. Therefore I can say that by theorem of parallel axis, I could say that IT is equal to IC plus mr square. We will call this as IM. So IC is 20 plus mr square. R here is nothing but r by 2 the whole square. So this is going to be nothing but 20 plus mr square by 4. This is 20 plus mr square is 40 by 4. So 1030 kg meter square. Next, take down next one please. If the earth was suddenly shrunk, if the earth was suddenly shrunk to half its radius, if the earth was suddenly shrunk to half its radius, what would be the new length of the day? What would be the new length of the day? What would be the new length of the day? Right? Now, I can say that Earth can be considered as a sphere. Right? Now, moment of inertia of a sphere about its diameter. If it is going to rotate, or it rotates on its own axis, right? So in that case, that axis is nothing but the diameter. Therefore, I can say that moment of inertia of sphere about its diameter is nothing but, let's call that as I, which is 2/5 mr square, right? Once you have this, I can say that since no external torque is acting on the earth, even when the earth is reduced in size, the angular momentum of the earth should remain constant. Since no external torque acts on earth, since no external torque acts on earth, therefore I can say that I1 omega 1 should be equal to I2 omega 2 by law of conservation of angular momentum. Now I1 is going to be 2/5 mr1 square omega 1 square should be equal to I2 2/5 mr2 square omega 2 square, right? In which case I could say that 2/5 and m gets cancelled, 2/5 and m gets cancelled, so I'll get r1 square. This is omega square is not there. Okay, this is omega 1 and this is omega 2. Now r1 square omega can be written as 2 pi upon t is R2. R2 is nothing but R1 upon 2, because they said that the earth was suddenly shrunk to half the radius. So I can therefore say R2 is nothing but R1 upon 2 the whole square into 2 pi upon T2. Right? Once I have this, then I can say that R1 square 2 pi gets cancelled upon T1 is nothing but R1 square upon 4 T2, right? So in that case you will get T2 is T1 upon 4. Now the length of the day with the present size of the earth is 24 hours, so T2 would be 6 hours. Then the length of the day would be 6 hours, right? Take down next one please. Determine the kinetic energy of a circular disc. Determine the kinetic energy of a circular disc rotating with a speed of 60 rpm rotating with a speed of 60 rpm about an axis passing through a point on its circumference. Passing through a point on its circumference. And perpendicular to the plane. The disc has a radius. The disc has a radius of 2 meters. The disc has a radius of 2 meters and mass of 10 kgs. The disc has a radius of 2 meters and a mass of 10 kgs. Now first of all, they give you n is 60 rpm. So this is nothing but 60 upon 60 rps. Okay, let's move on. They've also given you that it has a radius of 2 meters and mass of 10 kgs. Right? Now, first let's find out moment of inertia of a disc about an axis passing through its center. Is nothing but mr square by 2. We'll call this as IC. Right? Now, I can say that therefore moment of inertia about an axis passing through the circumference IO can be given by theorem of parallel axis. If I apply theorem of parallel axis, I can say that IO is equal to IC plus mr square. So IO is equal to mr square by 2 plus mr square. This is nothing but 3 mr square by 2. Right? Now once I have this, I know the moment of inertia, then I can find out the kinetic energy. Kinetic energy of rotation is half I omega square. This is nothing but half I is 3 upon 2 mr square. Omega is nothing but 2 pi n the whole square. I know m, r and n. I should be able to get the answer for this sum. The answer for this sum should be 1185 joules. Next, calculate the angular momentum of the earth. Calculate the angular momentum of the earth due to rotation about its own axis. Due to rotation about its own axis. Assume the earth to be a sphere. Assume the earth to be a sphere of mass 6 into 10 raised to 24 kgs and radius 6,400 kilometers and radius 6,400 kilometers. Now they're saying that calculate the angular momentum of the earth due to rotation. Now if it is rotating, it is going to rotate about its diameter. So first let's find out the moment of inertia of earth about an axis passing through its diameter. Is going to be nothing but 2 upon 5 mr square, right? Now in that case, once I have this, I can also say that omega is nothing but 2 pi upon t, right, where t is 24 hours, which is nothing but 24 into 3600 seconds. Now they've asked me to find out the angular momentum of the earth. Angular momentum L is nothing but I omega, right? I have already found out, that's 2 upon 5 mr square. Omega is nothing but 2 pi upon t, 2 upon 5 mr square into 2 pi upon t. I have all the values m, r and t. I can substitute and get the answer. The answer for this sum should be 7.149 into 10 raised to 33 kg meter square per second. Next, take on next sum please. Calculate the moment of inertia. Calculate the moment of inertia of a thin rod. Calculate the moment of inertia of a thin rod of mass 10 grams, and length 60 centimeters about an axis perpendicular to its length and passing through first part of the question, through its center. Second part of the question, through one end. Also find the radius of gyration. In both cases. Now, moment of inertia of a rod about an axis perpendicular to the rod and passing through its center. IC can be given by the formula ml square by 12. I know m, I know l, I should be able to get this answer. And in that case I can also say that radius of gyration kc is square root of I by m, IC by m. You will have the value of IC, divide that by m, you will get your answer, right? Next, second part of the question, about an axis passing through one end. I can use theorem of parallel axis. I can say that by theorem of parallel axis, IO is equal to IC plus MR square. So IO is equal to IC, that is ML square by 12 plus M. R here is nothing but L by 2. So L by 2 the whole square, right? In which case you will get this as ML square by 12 plus ML square by 4. 12 is the common denominator. So this is going to be nothing but 4 ml square by 12, which is nothing but ml square by 3. Once you have this, you know m, you know l, you should be able to get the answer. Again, the radius of gyration here, KO, is going to be square root of IO by m. You should be able to get this answer. The answer for this sum should be IC. IC is going to be 3000 grams per centimeter square. Grams centimeter square, not per. Then KC is 17.32 centimeters. Then you have IO should be equal to 12,000 grams centimeter square. And KO should be equal to 34.64 centimeters. Next, take our next one, please. 4 particles of mass 4 particles of mass 1 gram, 2 gram, 3 gram and 4 grams are situated at points minus 1, 2, 2, minus 1, 2, 2. Second point is 3, 2, minus 1. Third point is 1, minus 2, 4. And the fourth point is 3, 1, 2. Find the coordinates of the center of mass. Find the coordinates of center of mass. Let the coordinates of center of mass be x, y, z, in which case I can say that x is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 upon m1 plus m2 plus m3 plus m4. Similarly, I can find out y, which is m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 upon m1 plus m2 plus m3 plus m4. Similarly, I can say z is equal to m1 z1 plus m2 z2 plus m3 z3 plus m4 z4 upon m1 plus m2 plus m3 plus m4. Right? The answer for the sum should be The answer for this sum should be x comma y comma z is going to be 2 comma 0.4 comma 2. Next, take down the next sum. 3 particles of mass, 3 particles of mass, 3 particles of mass, 1 gram, 3 grams and 6 gram, 1 gram, 3 grams and 6 grams have position vectors, 5i vector plus 7j vector plus k vector. B vector is 2i vector plus j vector plus k vector, and C vector is 3i vector plus j vector plus k vector. Find the position vector of the center of mass. Find the position vector of center of mass. Find the position vector of center of mass. Nice. Since the position vector is given to you, you can find out the coordinates of the point. I can say A x1 y1 z1 is A 5, 7, 1. B x2 y2 z2 is B 2, 1, 1. And C z x3 y3 z3 is C 3, 1, 1. Once you know the coordinates of the point and you know the 3 masses, you should be able to get the answer. It is replica of the previous sum, right? Where I could say that x is equal to, I'll first say let coordinates of center of mass be x comma y comma z. Therefore I can say that x is equal to mx1 plus m1x1 plus m2x2 plus m3x3 upon m1 plus m2 plus m3. Y is equal to m1y1 plus m2y2 plus m3y3 upon m1 plus m2 plus m3, and z is equal to m1z1 plus m2z2 plus m3z3 upon m1 plus m2 plus m3, right? The answer for the sum should be 2.9, 1.6, 1. Next, take our next sum please. Two wheels of moment of inertia, 4 kg meter square and 2 kg meter square rotate at a rate of 120 rpm, and 240 rpm in the same direction. If the two wheels are coupled, so as to rotate if the two wheels are coupled so as to rotate with the same angular velocity, so as to rotate with the same angular velocity, find the resultant speed of revolution. Find the resultant speed of revolution. Find the resultant speed of revolution. Now, let's find out what would be the initial angular momentum. The initial angular momentum L1 will be nothing but I1 omega 1 plus I2 omega 2. That will be my initial angular momentum, which can be written as I1 omega 1 can be written as 2 pi n1 plus I2 2 pi n2, right? So in that case I can say 2 pi I1 n1 plus I2 n2. That will be my initial angular momentum. Let n3 be the speed of revolution after the wheels are coupled. So in that case, I can say what will be the final angular momentum. The final angular momentum L2 will be nothing but I1 omega 3 plus I2 omega 3. Why both of them I am writing as omega 3? Both of them I am writing as omega 3. Both of them I am writing as omega 3 because after coupling both the wheels are going to be moving with the same speed. So this is going to be I1 2 pi n3 plus I2 2 pi n3. So this is 2 pi I1 n3 plus I2 n3. Now I can say by law of conservation of angular momentum, I can apply law of conservation of angular momentum. By law of conservation of angular momentum, I can say that L1 should be equal to L2. The total momentum before impact should be equal to the total momentum after impact. So in that case I can say that 2 pi I1 n1 plus I2 n2 should be equal to 2 pi I1 n3 plus I2 n3. 2 pi gets cancelled. I'll get I1 n1 plus I2 n2 should be equal to I1 n. I could take n3 common. I1 plus I2. You have all the values. You can substitute and get the answer. The answer for this should be n3 is 160 rpm. Next, take on next one please. The kinetic energy of rotation of a body. The kinetic energy of rotation of a body about a given axis. The kinetic energy of rotation of a body about a given axis is 157 joules. Its angular momentum is 12.5 kgs meter square per second. Find the frequency of rotation. Find the frequency of rotation and the moment of inertia. Find the frequency of rotation and the moment of inertia. They've given you kinetic energy, they've given you angular momentum. Now I can say divide the two. Kinetic energy upon angular momentum will be 157 upon 12.5, but kinetic energy is half I omega square. Angular momentum is I omega is 157 upon 12.5. I and I gets cancelled. Omega and square gets cancelled. So I'll get omega upon 2 is 157 upon 12.5. But omega is nothing but 2 pi n. What do they ask me to find out? Find the frequency. Right? Omega is nothing but 2 pi n upon 2 is 157 upon 12.5. Therefore, I'll get n is 157 upon 12.5 into pi. Right? So that will give me the frequency. Right? Once you have the frequency, find the frequency of rotation and also find out the moment of inertia. Moment of inertia, I can say L is equal to I omega. L I already know is 12.5 is I. Omega is nothing but 2 pi n. I already have found out the value of n, so I should be able to get the value of I. I would be the only unknown there. The answer for this sum should be n is 4 Hertz and I is 0.4976 kg meter square. Right? This finishes this chapter. We'll stop this here for the day. Thank you very much.